All right, lesson 3.6 is solving systems of linear equations with three variables. If you'll remember back when we solved systems of equations with two variables, they looked a lot like x plus 3y equals 8, where they had an x and a y, or 2x plus 4y equals 12, where you actually got an x variable and a y variable, and if you remember, whatever our solution was, it had to work in both equations. Well, what we're actually going to be doing in this lesson is we're actually going to have three variables: an x variable, a y variable, and a z variable. And just like this one, the first variable is the x, second variable is the y, and the last one is z. Okay? And just like when we did two variables, in order for this to be a solution, 6, 0, negative 3 to be a solution, it has to work in all the equations. And just like two variables, all you have to do is plug in the equations and make sure they work. So for example, so if we plug in, our x is 6, so we're going to do 5 times 6 minus 4, y is 0, plus 4, and z is negative 3. And that has to give us negative 18. So we find out 5 times 6 is 30, 4 times 0 is 0, 4 times negative 3, we're going to make that a negative 12, equals 18. So you find out 30 minus 0 minus 12 gives us 18. So it works in the first one. And we'll put a little check here to tell us. So then remember, this is an invisible 1. So we have negative 1. Our x is 6 plus 3 times our y is 0 minus 2 times, and our z is negative 3. And that one has to equal 0. So we find out negative 1 times 6 gives us a positive 6. 3 times 0 is 0. And negative 2 times negative, this should be a negative. Negative 2 times negative 3 is negative 6. I mean positive 6. So negative 6 plus 6, yes, that gives us a 0. So it works in the second equation. Okay. The next one, do the exact same thing, except 4 times our x is 6 minus 2, y is 0, plus 7, and our z is negative 3. And that one's going to have to equal 3. So 4 times 6 is 24, 2 times 0 is 0, and 7 times negative 3 is going to give us a negative 21. So 24 minus 0 minus 21 does give us 3. So since it works in all three of them, it's an equation. So remember, if it doesn't work in any one of them, it can work in one of them, and it's done. It's not a solution. Make sure you check your math, though. Common mistakes are with the negatives and positives. As you notice, even I made a couple of mistakes in there. Okay. The second part of this, we're actually going to give you an equation. We'll come back to this in just a second. I'm actually going to give you an equation just like this, and you have to actually find that solution. Okay, so solving systems of equations with three variables. So basically, here are the three steps, and you should be able to find these on Angel right above the video. So basically, you need to decide in your equation, you've got an x, a y, and a z in all of the equations, and you need to decide which variable you're going to eliminate. Okay, you can combine any of the two equations, then you're going to combine a second two equations, eliminating that second variable. Because our objective is, what we're basically going to do is we have three variables. We're going to eliminate one of them, get it down to now two variables. Then you're going to use the elimination method, and you're going to eliminate the second variable to get it down to one variable so you can actually solve this thing. Okay, and then you're going to, once you get that last variable, you're going to work your way backwards to find out what the other two are. So let's take a look at this. So we have 3x plus 2y minus z equals 8, negative 3x plus 4y plus 5z equals negative 14, and x minus 3y plus 4z equals negative 14. So this is one that these require a lot of work. So a couple things to that. First of all, you are going to have to submit your handwritten assignment for this problem. Make sure you scan it in, put it in a Dropbox. You could also type it in a word processor and submit it. That's probably not the desired method. Scanning it in would probably be the best. So basically, remember, you've got to eliminate, you've got three variables. So the first thing is we need to eliminate one of the variables. It doesn't matter which one we're going to pick, but you need to eliminate one of them. And when you decide what we're going to do, you need to stick with that until you get it down to 2. So I'm looking at these, and I already have Remember, we have to have the same coefficients. I already have a positive 3 and a negative 3. So I'm going to decide I'm going to eliminate x. Okay? So if I eliminate the x, just like we did before, I'm going to add the equations together to get it down so I have only a y and a z left over. So if I notice, I already have same coefficients and different signs. So I'm going to add the first two equations together. So 3x plus 3x cancels out. 2y plus 4y gives me 6y. Negative z plus 5z gives me a 4z equals an 8, and negative 14 gives me a negative 6. So just like we did before, nothing's different. Only thing is now we have three variables, but we're combining two of them. Okay. So the second equation, I have to put a different pair of equations together. I still have to eliminate the x because my ultimate goal is to get it down to have just y's and z's. So I'm going to go ahead and I'm going to put these two equations together. But in order to do that, remember, I still have to eliminate x's. So the coefficient on the first one is negative 3 already. So I need to make this one a 3. Okay, this is the place that you want to go really, really slow and make sure that you've done your multiplying right, because there's plenty of errors or plenty of time for error. So I don't have to do anything to the top one, so let's just rewrite this. Negative 3x plus 4y plus 5z equals negative 14. And the bottom one, remember, everything has to be multiplied times 3. So 3 times x gives me 3x. 3 times negative 3y gives me negative 9y. 3 times 4 gives me 12z. And 3 times negative 14 gives me a negative 42. Now that I have the same coefficients on the x's, I can combine those two, so it'll eliminate the x's. And I will have left over, once I eliminate the x's, I'll have my y and my z left over. So 4y, negative 9y gives me a negative 5y. 5z plus 12z gives me a 17z equals a negative 42, and a negative 14 is going to give me a negative 56. Now I will tell you, because the multiplying and the adding that goes on, some of these numbers are going to get really, really large. Okay, so just be careful of that. So now we've got it down to, we've eliminated the x's, so now we've got two equations with two variables, a y and a z. So we're going to follow the exact same procedures, but this time we need to decide whether you want to eliminate the y's or you want to eliminate the z's, because you're just now going to eliminate a second variable. Okay, so now we're going to eliminate a second variable. Okay, so I'm going to go ahead and do y's. You could do the z's, and there's two reasons I'm picking the y's. One, I don't have this 17 that I'm worried about. The second of all, I already have a negative and a positive. So I got to get the same coefficient, so I'm going to multiply this one by 5, and I'm going to multiply this one by 6. So 5 times 6y gives me 30y. 5 times 4 gives me 20z. And 5 times negative 6 gives me a negative 30. And then on the bottom, 6 times negative 5 gives me a negative 30y. 6 times 17, and this is one that you're going to have to really, really make sure that you're really careful. So let's do 6 times 17 gives me 102z equals, and then 6 times a negative 56 gives me a negative 336. Okay, so now I have the same coefficients. So when I eliminate my y's, those will cancel out. 120 plus 102 gives me 122z. A negative 30 and a negative 336 gives me negative 366. Divide. And z equals negative 3. Okay, so let's go ahead and put that in an ordered pair. Remember, the z comes last. Now, the worst of the work is, most of the work is done. So once you've got it down to where you've eliminated it down to one variable, you've eliminated the second variable, you've got it solved, now you're going to work your way backwards. So go back to the equations where you had two variables, and you just need to take what your z value is and plug it in. Doesn't matter which equation, because remember it's supposed to work in both of them. So I'm going to go ahead and plug it in the first one, and everywhere I see a z, I'm going to put -3. So I get 6y plus 4 times -3 equals -6. So 6y, 4 times -3 gives me -12, equals -6. Add 12, and 6y equals 6. So divide by 6, and y is 1. So my y is 1. And then the last step is I'm going to go, now that I've got two variables, you're going to go all the way back to one of the originals. And again, it doesn't matter which one you plug it in, but we need to plug it in one of them. So we're going to plug it in the bottom one. So I get x minus -3, x minus 3 times my y is 1 plus 4 times my z is -3 equals -14. So x, -3 times 1 is a -3, minus 12 equals -14. So I get x minus 15 equals a -14, and then I add 15. So my x is 1. Okay. I will tell you a little secret when you're solving these. All of your answers should come out to be whole numbers. We understand this is a lot of work, so in the process we just want to make sure that you're solving this. So that's one quick check that you can do. It is possible to get fractions and decimals when you're actually solving these in real life, but for our purpose, all of your answers should have come out to be whole numbers. Just make sure you take your time, show your work. There's a lot, like I said, there's a lot of errors for mistakes. So we've provided a couple of other examples that you can go ahead and take a look at, so please feel free to take a look at those. Do several of the practice problems before doing the quick check. Make sure you're getting them correctly. If you need any help, please contact myself or your instructor, and good luck.